Hiya folks. So today's lecture will be arguably a little dry. We're going to be talking for the last time about asymptotic analysis only, and in future weeks we'll use asymptotic analysis towards practical purposes. So I'm going to start by introducing a thing called Big O notation, which will be closely related to our Big Theta notation from before. It's a good thing to know about to be a good citizen of the world. So I'll start by reminding you of what Big Theta is. So Big Theta was a way to, given a function, describe the order of growth of that function in a nice, concise, mathematically precise way. So for example, the function n cubed plus 3n to the fourth, we said that it was big theta of n to the fourth, or equivalently, that its order of growth was n to the fourth. Okay. Now we also use big theta not just to describe functions like these, but also the runtime of pieces of code. And you can also use it for space, though we have not done so yet. So for example, binary search on n items, we can say that the runtime of binary search, in the worst case, is big theta of log n. Okay. Now big O is actually a very closely related idea. So whereas you can think of big theta as something like equals, you can think of big O as less than or equal. So for example, if we have the function n cubed plus 3n to the fourth, we could say that it is big theta of n to the fourth, but we could also say it's big O of n to the fourth, because this function's order of growth is less than or equal to n to the fourth. It is also big O of n to the sixth, because its order of growth is less than or equal to n to the sixth. It is also big O of n factorial, n to the n factorial, or any other family of functions that grows faster than n to the fourth. Okay? So that's the idea of big O, just informally, and we'll talk about why it's useful in a moment. But before we get there, let's put it on a rigorous ground. So big theta is as you may recall, we had this very formal definition where we said that R of n is big theta of f of n if it could be bounded below and above by scaled versions of the function that it is big theta. So this picture as a reminder, if we, okay, there we go. So this red function is the R of n, and these are the scaled versions of f of n, just a reminder. And as you can see, it is between a small and a big version, so then we can say that it is big theta of f of n, in this case, n squared. Okay. So big O, very similar, is you just drop that bottom line, right? Or that bottom function. We don't care about k1 times f n anymore. Now it's just we're bounded above. Okay, that's it. So for example, if we take the function 40 sine n plus 4n squared, we can say that it is big O of n to the fourth, because, well, here's our runtime function. Here's my f of n to the fourth, and I pick k2 equals 1. And if we look at the visualization of this thing, okay, hurry up, internet. Okay, here we go. If we look at what we got here, here's our function, and here's our f of n, and as you can see, it is much smaller, right? It's way, way, way smaller. So this function is, n to the fourth is much, 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 much bigger than our 4n squared plus 40 sine n, so therefore it is big O of n to the fourth. That's it. Okay, so not a lot to it. So comparing big theta and big O, we can say the informal meaning of big theta is the order of growth is f of n, and for big O, it's that the order of growth is less than or equal to f of n. So if we think about each of these expressions, say big theta of n squared as a family of functions, we can enumerate a bunch of different functions which are in that family. So for example, 2n squared is in the family theta n squared. N squared plus 38n plus n, all of these are in the family theta n squared, all three of these functions given. By contrast, big O is a family which is more inclusive. So when we say big O of n squared, that includes n squared over 2, 2n squared. It also includes n squared plus 38n plus n, and it also includes even smaller functions like, say, log n. Okay, so that's it. That's all there is to big O, and we'll see why it's useful soon. And that's it for this video.